Hey dudes, welcome to Trig. We're going to start off with just looking at radian measure. Likely you've seen that before. I'm assuming in like extended you saw radian measure, but we'd like to be able to work in both systems, so I want to give you a refresher about that. All I want you to be able to do with this is switch back and forth from radian to degree. So if you're comfortable with that, maybe fast forward this, but I think that this idea will help the concept sink in. The Babylonians were the first set of people to start breaking up circles into pieces for fun and profit. And they used 360. They broke them up into 360 little tiny slivers. And there's a lot of stipulations about why they broke it up into 360. It's close to approximating how many days in the year, and so it works for like things like sundials somewhat nicely. It's also a really nice number. It divides by 2 and 4 and 6 and 12 and 30. It divides by the number of months, the number of seasons. So it was a useful piece to divide by. So in one full spin of the circle, if you go all the way around, so one revolution, there's 360 of these pieces that have an angle. They subtend an angle of 1 degree. Fine. So if you haven't already, hopefully you can put these into your unit circle. We start at 0. This is sort of where we start off, and as we angle up, we start angling up because this is where the positive x's and the positive y's are. So we start going up into the first quadrant. That's why they call it the first quadrant, actually. And so the first angle you get to is 30, and then 45, and then 60, etc., etc. One thing to note that people get tripped up on is that this chunk is 30 degrees, and so is this, and so is this, right? 30, 60, 90. I know that on the unit circle there's another piece in here, but this is 30, sorry. This is 30, and this is 15, and this is 15. Just be careful of that. Same thing all the way around. So there's your angles. I assume that you can take one unit circle and just put in all your angles and not have to think too much about it. In degrees. There's another way to measure angle, just like there's other ways to measure temperature and things like that, and that's a radian. We call it a radial angle, and so it's abbreviated as radian. And if you think about this in this fashion, if you go all the way around the circle, if you started here and you walked all the way around the circle, you would walk the circumference, which is 2 pi r. It'd be 2 times pi times the radius. This is, pi is around 3, so this is about 6 times as much as the radius. So if you took this radius, you'd walk about 1 of them to here, 2 of them to here, 3, 4, 5. Oh, I'm off a little bit. 6. And so you get about 6, right? And I was off because it's about 6 times the radius, and that's just a fundamental property of circles. Oh, there we go. This, if you were to do this, if you were to walk out to the edge, walk up this same distance r, this angle that is subtended, means traversed, right? This angle that you've subtended, theta, is 1 radian. Sometimes we abbreviate it rad. Sometimes they use they use other symbols for it. But 1 radian is, if you walk from one point an entire radius to a different spot, that angle that you've subtended we call 1 radian, and it's really useful and easy to use once you get the hang of it. Let me give you a better visual of this. I like this this visual. Here's a radius, here's another radius, right? So you can see that they're the same length, although this is curved around. So this angle that you would subtend between this line, both of these radii, is a radian. Here's a visual that I like about how to see it happening. You pull the radius out and then bend it around, and that's 1 this angle is 1 radian. Cool? Yeah, let's replay it. That was awesome. Whoa. Whoa. All right, great. So radius out here, and you've subtended a radian angle. Cool. And you get about 6 of those, right? Because you get about 6 of them all the way around because the circumference is about 6 times the radius. Great. I want us to be able to bounce back and forth between radians and degrees. When we use radians, we use this little degree symbol. Sorry, degrees, we use the degree symbol. Radians, usually either, I like to see rad or blank. Sometimes they use a little C. Sometimes they use a big R. I think that's obnoxious, but that's just personal preference. It's sort of like determining, is it called slope or gradient? It's just what you use locally. To be able to switch back and forth between them is not too bad. You're just using a proportion. And you can think about this, like halfway around the circle is 180. It's also pi radians. Yeah. And that's because this is like 1, 2, 3. It's half of the circumference, right? It's half circumference, which is 2 pi r. It's half of 2 pi r. And since the 2 and the half cancel and r on a unit circle is 1, that's why it's a unit circle, you just have pi as halfway around, right? And if you go the full distance around, that's 2 pi. Because the full circumference is 2 pi r. If that's unclear to you at this point or vague, we'll look at that more in depth. But I suppose just for this set, trust me on that all the way around the circle is 360. It's also 2 pi radians, right? So we can use those to switch back and forth by just thinking about a proportion, yeah? And it doesn't matter how you set up the proportion. If you're changing from 120 degrees and we want to change it to radians, actually I like to work it a different way than this. I like to say, all right, the piece in degrees, that fraction, right, the part that we go around 120 degrees is like there. And the part that we go around over the total, that'll be the same fraction, same ratio going from here to here is the same ratio in degrees as it is in radians, right? So this divided by all the way around is the same relationship as this in radians, which I don't know right now, divided by all the way around in radians, which is 2 pi. You can set up your ratio in different ways, but I like this. This makes the most sense to me. And then you can cross multiply. So this is 240 pi equals 360 x, and radians are going to have pi in them normally, so leave it. So this is 240 pi over 360 is your x, and then you can clean this piece up. Right, so this becomes, leave the pi, this becomes 24 over 36 pi equals x. And then what, you can, I don't know, divide by 6, and you get 6 and 4 and 2/3. So you get 2 pi thirds is x. All right, I'm kind of cruising through that because I assume that you've seen that. So you can call 120 degrees 120 degrees, or its equivalent is 2 pi thirds. Just like 100 degrees Celsius is 212 Fahrenheit. They're equivalent. They feel the same when you put your hand in the water. So let's look at, let's change this one around, right? 3 pi halves, let's change it to degrees, right? Well, 3 pi halves is a piece of the full circle. Out of the full circle is 2 pi. And that should be the same as the degree measure over the total in degrees. And then we cross multiply. So this becomes 2 pi x, and 3 times pi times 360 right, over 2. There's pi's on both sides. They cancel out. This is 360. This becomes, what? You get x on this side, and you can just run it through your calculator if you like, but this is 3. Once we divide this 2 off of both sides, this is 3 times 360 over 4, and I think that simplifies. This divides, becomes 90 times 3, 270. Cool. It's not my intention to watch you do like the mental math, but hopefully you can simplify to this to 270. Great. So that's all I want you to be able to do. Go back and forth from degree to radian. If you're confident, go for it. If you're not confident, I'm going to try these 4. So let's give it a shot. 60, right? We know that's the piece out of the whole, should be the same as the radian measure out of the 2 pi. And let's do this. Just so you can, just so you can check your work if you want to just run these through and check them all at once. I got, this is pi thirds, this is 3 pi fourths, and this is 30 degrees, and this is 135 degrees. If you'd like to see those done, here we go. So we set up a proportion, we multiplied across, so this is 60 times 2 pi, so 120 pi, equals x times 360, or 360x. And when you divide, you keep that pi sitting there. We want pi in the answer, and you do 360 over 120 over 360. These cancel out, and then you divide by 12. You get 1 on top and 3 on the bottom, so you get x is pi thirds. Ching. This you do the same sort of thing. Let's do it in green. So you go 135 over 360. The part of the circle over the whole over the circle equals the piece in radians over the whole in radians. And so you get 360x equals 2 times 120 is 270 pi when we do these. And then you divide, right? So you get 270 pi over 360. The zeros cancel and you get 27 over 36. You can divide them by 9. And you get x is 3 pi fourths. It gets a little uglier with these. You have to do some fraction work. So it's the part over the whole equals the degree over the whole in degrees. And when you cross multiply them, you can think about it this as 360 times pi all over 6. And on this side, 2 pi x. Doesn't really matter where pi is because we can divide it out. And when you divide this across, you get 360 over 12 equals x. That ends up being 30. Same sort of thing here. This is 3 pi fourths over 2 pi. Should be the same as the degree measure over 360. And when we cross multiply, you get 3 times pi times 360 all over 4 equals 2 pi x. 2 pi x, yep. And your x's your pi's cancel out. The 360 over 4 is 90. And you get, 3 times 90. And then when you divide, you have to divide this 2 off. Divided by 2. So this is really 45 times 3, which is 135. Cool. That's it. I'll see you in class. We're going to try these out, and we'll catch up then. Bye.